Okay, fine. A very good morning, good afternoon, be it anything at any time you're watching it, but just make sure that before you come before you come back to school, please watch the entire series or whatever number of videos which you all will get. Please watch it. Means I'll make sure that I'll be posting about 2 videos per day, so make sure you just watch it, make a note of it. Please make a note. Please make a note. I'll be posting the video link as well as the PDF notes. Please make sure you make your own notes. That's the first and the most important thing. And the moment you come back after the vacation, we'll have a quick unit tests on each of the chapters. If you'll have any doubt, we'll go through all the doubts, then we'll conduct tests, because only conducting a test will make sure have you actually understood the chapter or not. Without any further delay, let's start now. Chalo. Okay, we'll be starting with a new chapter named Current Electricity. This will be the first episode, and we'll be starting with charges and current. So let's get started. Okay, now the first thing that we need to understand is that the story means एक कहानी है. The name of this film is Current Electricity, and in this movie we have three main characters. We have three main characters. दिख रहा है आपको यहाँ पर? This is character A, this is character B, and ये जो बंदा है, this is character C. Fine. You can understand in simple. Let's give it very simple. This person C will treat it as the villain of the story. He is the villain of the story, and this person A acts as the hero of the story. Fine. And let us assume some here and there that this person C will be the heroine of our story. Now what happens is simple. Over here we have a heroine. She tries to move. She will do it. Just observe the figure. देखो ये this character A tries to move, across a certain region, but this person A alone cannot move. So this requires an external push or a dhakka. So this push is given by a hero of a story whose name is potential. Potential. And this person which moves is termed as current. इसका नाम current है. ये जो push कर रहा है, जो धक्का दे रहा है, उसका नाम potential है. And if you look at the villain of the story with a big mustache over here, big mustache, the villain of the story, he makes sure that this current does not move easily. What is the current saying? I am not traveling very fast. Oh, I'm not traveling very fast. Why? Because this person named resistance is not allowing this current to move smoothly. Fine. So we have in the style story named Current Electricity, we have three characterizations. First is the current, next is the potential, and third is the resistance. Current wants to flow, potential is the one responsible for making the current to flow, and the resistance opposes the motion. Current pushes the motion, resistance opposes the current. Potential pushes the current, resistance opposes the motion. That's it. So in the upcoming 3 videos, we'll just introduce to our characters, and after that we'll move on to the climax of the movie. Fine, enough of details, let's move further. Now when we talk about current, we cannot proceed any further unless you know about something called charges. Now see, if you understand very carefully, देखो, if we understand the basic Bohr's BOHRS, Bohr's model. What does it actually say? It simply says that we have a atom. Suppose we have a atom. It says that the atom as a whole is electrically neutral. Electrically neutral कहने का मतलब क्या हुआ? अच्छा, first let's understand this constituent of atom. How does it actually looks like? We assume that atom is made up of something called nucleus. This is the nucleus which is positively charged. Why is it positively charged? Because this nucleus is actually made up of protons and neutrons, and these protons happens to be positively charged, whereas the neutrons happens to be neutral, no charge at all. इस पर कोई charge नहीं होता, neutral. And it also says that these nucleus are surrounded by orbits or shells. These are surrounded by orbits or shells. ये हो गया orbit, ये भी एक orbit, ये भी एक orbit. And I hope you remember that the last shell, the last orbit is what is also termed as valence shell. VALENCE, valence shell, or the outermost orbit is termed as valence shell. बहुत बढ़िया. And then we have studied that in these cell or orbits we have something called electrons, and these electrons turn out to be negatively charged particles, subatomic electrons, and these electrons turn out to be negative charged particles. And as a result, in general atom is neutral. When we say the atom is neutral, this means that the number of electrons is same as the number of proton. I'm sorry. Just give me 1 second, bhaiya. When we say the atom is neutral, this simply means that the number of electrons is actually equal to number of protons. यहाँ पे number of electrons कितना है? Number of electrons 4 है. So the number of protons will also be 4 because they are electrically neutral. Fine. Okay. Now suppose somehow, let's assume we remove 2 electrons. So as a result, what will happen is we'll have deficiency of electron. Deficiency of electron. Once we have deficiency of electrons, so over here the number of protons will remain the same, that is 4, but electron has been removed. So number of electrons has decreased by factor 2. Now since we have deficiency of electron, means negative charge कम है, negative charge कम है तो positive charge ज़्यादा है. So we say this atom is now converted into ion. And what kind of ion? Positive charged ion. And this positive charged ion is given a name called cation. अब atom नहीं रहा, ion बन गया, and this is called cation. Okay, this happens when we remove electron. But suppose in the same atom we add electrons. We add 2 electrons. The moment we add 2 electrons, over here the number of protons will still remain same, that is 4, whereas the number of electrons, since we are adding to it, number of electrons will increase. As a result, we'll have 6 electrons now. Now as we see over here, the constant number of electrons increases. That means we have excess of electrons. If we have excess of electrons, मतलब negative charge dominate करेगा, because electrons are negative charge. And then we say that this atom is now has become an ion. What kind of ion? Negatively charged ion. And this negatively charged ion is given a name called anion. Fine. Fine. So in general, we have basically we have two types of charge. One is your positive charge, and the another one is a negative charge. And we have a property that opposite charges they attract, similar charges they repel. This much so we all know, two type of charges. Fine. And since we are talking about fundamental subatomic particles, the smallest unit of charge कहाँ लिखे हम इसको? अच्छा एक सेकंड हाँ. When we are making a body charged, positive ion or charged negative ion, we talked in terms of electron. Either we removed electrons or we add electrons. Why don't we talk about adding proton or removing proton? We never talk about adding proton or removing proton. This is because the fact that protons being positively charged, they happen to be present inside the nucleus. न्यूक्लियस के अंदर होता है. अब न्यूक्लियस के अंदर से आपको प्रोटॉन निकालना, उसका कॉन्फ़िगरेशन चेंज करना, इट्स अ वेरी डिफिकल्ट जॉब इन द सेंस कि a large amount of energy is required, which is not, it is possible but we are not actually bothered about it, because इलेक्ट्रॉन्स को हटाने से ही हम लोग का बॉडी पॉजिटिव चार्ज और नेगेटिव चार्ज हो सकता है. तो व्हाई टू बॉदर अबाउट प्रोटॉन्स? प्लीज रिमेंबर द फैक्ट दैट when we talk about charge carriers, we'll talk about flow of electrons. Fine. Chalo. Now, acha, let's quickly analyze the concept of free electrons and bound electrons. Can I do it over here? No, I cannot do it over here. I'll quickly do it over here. Chalo. The concept of free electron and bound electron is very important. So let's try to understand. Just now we said that in a given atom, we have nucleus, and this nucleus happens to be positively charged, and after this nucleus we have shells, orbit 1, orbit 2, orbit 3. Depending upon what atom we are looking into, we can have a different number of shells. And in this shell, we have something called electronic configuration, according to which the electrons are distributed. Negatively charged, electrons, negatively charged, negatively charged. Again, suppose we have some electrons over here also, negatively charged, and some electrons over here also, negatively charged. Just now we told the fact that opposite charges, they attract each other with a force called electrostatic force or electromagnetic force, whatever you call. मतलब कि दो opposite charges के पीछे force होता है, तो कहा गया electrostatic force, and this force is inversely proportional to the separation between them. मतलब कि separation, दो चार्जेस के बीच में सेपरेशन जितना कम होगा, फोर्स उतना ही ज्यादा होगा. So when we talk about electrons, the electrons in the valence cell, valence shell, the electrons in the valence shell are very far apart. Let's look at this distance, suppose is r1. This distance r1 is very far compared to the electrons near to it. Suppose you talk about this electron, it is be r2. Now this electron happens to be at a less distance compared to this electron. Let this electron be A, let this electron be B. And just now, since ये दूरी ज़्यादा है, so the electrostatic force between electron B and nucleus will be less compared to the electrostatic force between the electron A and the nucleus. इलेक्ट्रॉन बी और न्यूक्लियस के बीच में जो फोर्स होगा विल बी वीकर कंपेयर टू द इलेक्ट्रॉन ए एंड न्यूक्लियस के बीच में विल बी स्ट्रॉन्ग. So what we understand that, I'll clear the statement, listen carefully, that the electrons in the outermost shell are loosely bound to the nucleus. These electrons are loosely bound to the nucleus. In other words, they are free. Why? Because the electrostatic force of attraction on that nucleus is very weak. As a result of which, this electron can come out of this orbit or out of that given atom. This free electron can come out of its valence shell and move around within the boundary of the matter or substance. It can easily move within the material of the boundary of the material. This electron can move around, but only within the boundary of the material, within the boundary of material. And these electrons in the outermost shell, these electrons in the outermost shell are the electrons which are termed as free electrons. Whereas the electrons which are very close to the nucleus, such that the electrostatic force is much stronger, so these electrons, they cannot move out of the valence shell, and such electrons are called bound electrons. So whenever we talk about electrons, first thing that must come out when we talk about flow of electrons, whenever we talk, what I'm trying to say is, means हम लोग जब भी flow of electrons का बात करते हैं, that means it is very obvious that we are talking about free electrons. And the moment this free electron comes out, the moment this free electrons come out, this atom changes into ion. What kind of ion? Positive charged ion, that is cation. Fine, fine. Keep this in mind. We'll use it at a later stage. Fine, chalo. Okay, done. Quantum nature of charge. ये सिंपली कुछ नहीं बोल रहा है, ये सिंपली बोल रहा है कि fundamental unit of charge is fundamental unit of charge is the charge of electron. Charge of electron. जो सबसे smallest possible charge है, the smallest possible charge that exists independently, important है, जो freely available है, listen to the words carefully, सबसे smallest charge, the smallest charge which is freely available, the smallest unit of charge which is freely available, which exists independently, is the charge of electron. And the charge of electron को हम लोग represent करेंगे small e से, and the value turns out to be 1.6 into 10 to the power minus 19 coulomb, where capital C stands for the word coulomb, unit of charge. And since electrons are negatively charged, we use a negative sign over here. And similarly, the charge of proton is also same. We say it is plus 1.6 into 10 to the power minus 19 coulomb. ये है smallest possible charge. बस इतना ध्यान रखेंगे, charge on electron is negative, charge on proton is positive. पर दोनों का मैग्नीट्यूड सेम होता है, और कितना होता है? 1.6 into 10 to the power minus 19. Great, fine. Now what quantization of charge says is that, अभी हम लोग को पता चल गया कि एक बॉडी पे जो स्मॉलेस्ट पॉसिबल चार्ज है वो है चार्ज ऑफ इलेक्ट्रॉन. तो अब अगर आपके पास एक बॉडी है, we have a charged body. You know what we have? We have a charged body. Now if the body is charged, and अगर आप मुझे बस ये बता दो कि इस पर नंबर ऑफ इलेक्ट्रॉन्स कितना है, n क्या है? n is the number of electrons. If you just give me the number of electrons, I can tell you what is the total charge on the body. Total charge on the body. ये बात समझ में आया? If you simply total charge Q, If you simply tell me what is the number of electrons on the body, I can tell you what is the charge on the body. एक चार्ज, एक इलेक्ट्रॉन का चार्ज मुझे पता है E, देखो चार्ज ऑन एन इलेक्ट्रॉन कितना हो जाएगा, बोल सकते हैं एन ई। बात समझ में आया? इट इज टोटल चार्ज ऑन अ गिवन बॉडी इज इक्वल टू एन टाइम्स, इसको बोलते हैं क्वांटाइजेशन ऑफ चार्ज। बात समझ में आया? अगर इस बॉडी के ऊपर 10 चार्ज इलेक्ट्रॉन्स है, so charge will become 10 into E with a negative sign because the electron has negative charge. If there are 50 electrons, the charge on the body will become 50 times E with a negative sign because we're talking about electrons. And E is the electronic charge. E क्या है? E is the electronic charge. Electronic charge. इसका मैग्नीट्यूड कितना होता है? मैग्नीट्यूड 1.6 into 10 to the power minus 19 कूलम। कहानी खत्म। इसी को बोलते हैं क्वांटिटेशन ऑफ चार्ज। ठीक है, लेट्स मूव फर्दर। ओके, वी हैव अ क्वेश्चन ओवर हियर व्हिच सेज हाउ मेनी इलेक्ट्रॉन्स आर रिक्वायर्ड टू कंस्टिट्यूट अ चार्ज ऑफ 1 कूलम। आपको बोला है कि आपके पास चार्ज है कैपिटल Q, इसका वैल्यू है 1 कूलम। आपको कितना इलेक्ट्रॉन्स लगेगा? ऑब्वियसली चार्ज है तो नेगेटिव साइन होगा यहाँ पर इलेक्ट्रॉन की वजह से, तो आपको कितना इलेक्ट्रॉन्स लगेगा ताकि आप इतना चार्ज प्रोड्यूस कर सको। ठीक है, लेट लेट देयर बी n इलेक्ट्रॉन्स। चार्ज ऑन ईच इलेक्ट्रॉन कितना है? E। चार्ज ऑन ईच इलेक्ट्रॉन कितना होता है? E, डिनोट बाय E, इसका वैल्यू होता है 1.6 into 10 to the power minus 19 coulomb. Fine, great. Now, can we not say total charge is equals to n times E? That means Ne is equals to Q. टोटल चार्ज कितना चाहिए आपको? सॉरी यहाँ पे नेगेटिव साइन होगा। टोटल चार्ज कितना चाहिए? 1 कूलम। n मुझे निकालना है, E का वैल्यू मुझे पता है -1.6 into 10 to the power minus 19 is equals to कूलम का वैल्यू दिया है -1। बात समझ में क्या हुआ? चार्ज का वैल्यू आपको दिया हुआ है 1 कूलम। इलेक्ट्रॉनिक चार्ज मुझे पता है कितना होता है, n है नंबर ऑफ इलेक्ट्रॉन्स। बस यहां से n निकाल लो, ये नेगेटिव पॉजिटिव हो जाएगा, तो n हो जाएगा 1/1.6 into 10 to the power minus 19। अब इसको सिंपली कैलकुलेट कीजिए। कैसे कैलकुलेट? इसको कैलकुलेट करने का एक सिंपल तरीका है, देख लो, वैसे ही करना प्लीज। 10 to the power minus 19 ऊपर जाएगा तो पॉजिटिव 19 आ जाएगा, ये हो जाएगा 1.6। अब इसको अगर हम और अच्छे से सिंप्लीफाई करें, इसको लिख सकते हैं हम 10 into 10 to the power 18। 19 था, एक 10 बाहर लिए, 18 बच गया, डिवाइडेड बाय 1.6। अब देखिए हम क्या कर रहे हैं, जानबूझकर हम ऊपर नीचे 10 से मल्टीप्लाई कर रहे हैं ताकि ये 10 into 10 ऊपर 100 हो जाएगा, नीचे 1.6 into 10 will become 16 and I'll have factor 10 to the power 18। अब कट्टम कुट्टा खेलो, ये हो गया 16, 4 4 जा 16, 4 25 जा 100। अब इसको डिवाइड कर दो, 4 1 जा 4, 4 6 जा 24, कैरी 1, फिर 0 जाएगा 10, 2 5 into 10 to the power 18, तो n आएगा आपका 6.25 into 10 to the power 18। तो अगर आपके पास इतना इलेक्ट्रॉन्स है, that means you have a charge of 1 coulomb। Please remember this, 6.25 into 10 to the power 18 electrons। If you have 6.25 into 10 to the power 18 electrons, that means you have 1 coulomb of charge। Great, let's move quick now। I think unit of charge is coulomb, COULOMB। symbol is capital C। अरे ऐसा लिखना मुश्किल लगता है मुझे, ऐसा पैकेज होता है। symbol capital C, symbol is capital C, coulomb। अदर यूनिट्स मतलब छोटा चार्ज या फिर बड़ा लिख सकते हैं, जैसे कि अगर आप बात करते हो मिली कूलम, ये हो गया 10⁻³ माइक्रो, माइक्रो मतलब होता है 10⁻⁻6 कूलम। नैनो, एन सी, नैनो कूलम 10⁻⁻9 कूलम। ये प्रीफिक्स है। मिली मतलब 10⁻⁻3, माइक्रो मतलब 10⁻⁻6, नैनो मतलब 10⁻⁻9। ठीक है, just keep that in mind. अच्छा, now when we are talking about electricity, that means the moment we talk about electricity, that means we are talking about charges, because charges, and when we're talking about conductor, we talk about electrons, but in general we talk about charges. Now when we talk about charges, and suppose when we study about charges or electron, in general when we study about charges, the property of charges when they are at rest, that branch of physics we refer as static electricity. Whereas when we study about the properties of charges when they are in motion, or then the branch which we refer is your current electricity, and this is the branch which we are interested at this moment, current electricity. That means we study about the motion of properties of charges when they are in motion, that is when the electrons are in motion. Fine, done. Electric current. In order to understand the word electric current, first thing that we need to understand is current का मतलब क्या होता है. Current means flow, flow of anything, flow of anything. Current means धारा, हिंदी में बोलते हैं धारा. If water flows we say water current, if air flows we say air current. What else can flow? Something, water, air, कुछ भी. But if something flows we say air flows, air current, water flows, water current. Similarly, when electrons or charges flow, when electrons or in general charges flow, we say it's an electric current. Air flows, air current. Water flows, water current. When charges they flow, we say it's current or electric current. Oh, bhai sahab. But oh, cancel. Fine. Okay. I think I should stop over here now. So I have 10 minutes. Well, fine, we'll stop over here. We'll continue in the next episode. Yeah, this is not good at all. I couldn't complete also this part. Some detection. I think I will do it. Fine, we'll just stop over here. Then we'll continue in the next slides. We'll continue it over. Thank you.